We see it in classrooms everywhere. A student tapping a smartphone screen, instantly rewarded with green check marks and digital confetti. It is the modern promise of educational technology that by integrating AI and gamified apps, we create active, engaged learners. But this engagement can be deceptive. Educators have observed a recurring phenomenon where students navigate these digital environments with ease, yet fail to retain the underlying linguistic patterns. A student might achieve high procedural fluency within an app's interface, racking up points and levels, while remaining unable to hold an unassisted conversation or write a coherent paragraph. When the digital safety net is removed, the linguistic ability often vanishes. This video examines why many digital tools fail to produce genuine language acquisition and how practitioners are re-engineering technology to prioritize cognitive growth over immediate correct answers. The central challenge is recognizing that digital interaction and immediate feedback do not automatically result in the construction of knowledge. To understand the failure, we have to look at how we learn. Lev Vygotsky defined the zone of proximal development as the space between what a student can do alone and what they can achieve with help. This specific space is exactly where genuine language acquisition happens. Visualize the ZPD as a chasm. A cognitive scaffold is a bridge, supporting learners to physically walk across through productive struggle. Now consider the lexical prosthetic. It replaces the bridge with a teleporter, beaming learners across instantly, completely bypassing the required cognitive journey. The prosthetic guarantees a flawless output. The assignment looks perfect, but because the brain did not perform the work, no residual knowledge is left behind. If a tool is designed to remove the friction of problem solving, it is no longer an educational tool. It is a shortcut that replaces the acquisition of the language. Language reference apps and online dictionaries occupy a complicated position in the classroom. Depending on how they are used, they can be the most effective scaffolds or the most limiting prosthetics. To acquire a word, 3 cognitive gears must turn: need, search, and evaluation. This powers the acquisition light bulb. But when a student clicks AI Translate, the search and evaluation gears freeze. The cognitive work is bypassed, and the light bulb stays dark. This creates a declarative trap. Students recognize sophisticated words on a screen, but lack the procedural fluency to actually use them in a novel sentence. Effective tools break this trap by encouraging active search behaviors, like cross-referencing corpus data or verifying synonyms, which force those cognitive gears to turn. The value of a digital tool is defined by the cognitive load it induces in the learner, not the speed at which it provides an answer. This distinction has become critical as students use large language models to automatically generate and upload pristine essays directly to their learning management systems. Traditional assessment, which focuses on grading a final submitted PDF, cannot distinguish between a student's work and an AI's output. The final product no longer proves that learning occurred. The response is process-based assessment. Within the LMS, teachers monitor a horizontal timeline of a document's version history, tracking an evolving draft. This timeline links to collaborative moments, brainstorming on digital whiteboards, and exchanging peer feedback. This method is resilient against AI because it documents the negotiation of meaning. An LLM can produce a result, but it cannot replicate the documented journey of a human learner. When perfect results can be generated in seconds, the only reliable evidence of acquisition is the recorded friction of the drafting process. We can see these principles tested in the Bangladeshi educational landscape, where theory meets a massive logistical divide. There is a stark divide between elite urban private institutions, which feature high-speed computer labs and seamless connectivity, and rural public schools, where load shedding or power outages can instantly disable digital environments, leaving teachers and students to work by flashlight. In these resource-constrained settings, forcing high-bandwidth tools like live video lectures often replicates the worst traits of a teacher-centered model, focusing on transmission rather than interaction. We can map these tools on a matrix that compares infrastructure demand against pedagogical yield. Passive AI usage or recorded lectures fall into the top left. They require high infrastructure but offer a low pedagogical yield. Deploying hardware does not trigger learning. Without a pedagogical strategy, technology can actually widen the divide it was meant to bridge. Because of these constraints, many Bangladeshi educators have turned to low-tech computer-assisted language learning. They bypass the need for a stable internet connection by using downloadable, offline podcasts, providing students with essential exposure to native speakers. Students listen to these files on mobile phones during power outages, turning periods of load shedding into mobile learning opportunities. For assessment, they use basic SMS text messaging on feature phones to send summaries to the teacher. This model plots in the bottom right quadrant of our matrix. It demands very little infrastructure but produces a high pedagogical yield. The SMS summary is particularly effective. The strict character limit of a text message forces the student to evaluate their vocabulary and summarize information with extreme precision. Strong pedagogical design can overcome infrastructural deficits. In these cases, the quality of the teaching determines the outcome, not the cost of the hardware. This reinforces the idea that the most important component of the classroom is not the tool, but the practitioner. This is the TPACK framework, where effective integration occurs at the intersection of technology, pedagogy, and content knowledge. When training focuses only on operating a device, the technology circle drifts away. The tool exists, but isn't integrated into learning. Teachers must move away from being simple transmitters of information. They are architects of digital networks and facilitators of the learning process. Stephen Bax describes a specific target for educational technology, a state called normalization. Normalization is the point where a digital tool becomes so deeply integrated that it is functionally invisible, used as naturally as a pen or a whiteboard. We cannot reach this state by simply dropping hardware into schools. It requires a sustained investment in the people who use it. Our standard for evaluating technology must change. We shouldn't ask how flawlessly it automates a task, but how effectively it forces learners to engage. The goal of technology is not to replace the cognitive struggle of learning. It is to build the scaffolds that make that struggle possible.